Hello everyone, this is Daryl. I work as a software developer, and in this video I'm going to be continuing my Let's Play of TIS-100. This is going to be level 11 that we do today, and we'll see if it's just as easy as the last one we did. This one is going to be Sequence Peak Detector. So let's give this one a shot. Sequences are zero terminated. Read a sequence from in, so we have two outs here. So we're going to read a sequence from in, write the min value to out.i and the max value to out.a. Okay. You're given these sequences, they're zero term. Okay. And in the case, like this last one I see here where there's only one value, it's the max and the min. Okay, so we're going to have to record them separately. Gotcha. So this one's definitely going to be a little more complicated than the last one. So what I'm thinking of doing is just have this one. So move up an ACC and then move ACC down and move ACC right. So this node, I'm thinking its whole purpose is just to take that in, and it's going to pass that value to both of these. And kind of like this path is going to be analyzing the minimum value and outputting, and this path is going to be analyzing the maximum value and outputting. So let's do the minimum path here. So we're going to want to store our minimum value in this BAK. And so I don't see it looks like the max values that can be in here are probably 99. Let me actually check real quick. Okay, so the registers can be between negative 999 and positive 999. So just to be safe, at the start of an iteration, I want to move. Well, actually, let me see. All right, so we're just going to move up to ACC. So first we're just going to accept the value. And it looks like we're going to need to use another node to store some of this because I want to then retrieve the value that's in BAK. But we're going to temporarily need to move this value around. So let's move. Maybe this actually makes more sense. So move up to the left. So just pass it straight over to that one. SWP, because that's where we're going to store the actual value. AEZ to EZ. EZ is just going to move 999 to ACC. And then we'll go here otherwise. So this is just the start of the iteration. So if after we swapped the value we had was 0, since 0 can't be a minimum because that's the terminating character, we know that we're at the start of a sequence and we can set it to 999, which is the max. And it looks like none of those ever get passed here. So that's a good max. But either way, you're going to end up here. And I think you want to save. So you want to keep whatever the current max is. And then you're going to sub left, which all this is going to essentially do is move right, right. Just take it in, push it back out. Here you're going to subtract whatever the left value is. So like let's say that we had 999 and we found a 10. So then this would be still greater than 0. So if it's not greater than 0 at that point, then we know if it's greater than 0, we know that that value is smaller. If it's not greater than 0, then it's not smaller. So we just want to jump to the end, which is going to be down here. But if it is greater than 0, and actually we will want to do that. So move right ACC, and then move ACC right, and then move ACC right. So we're going to basically just accept it and offer it up twice. Once to allow it to subtract, and then once to allow it to either accept it or deny it. So if it is, well, so if it's greater than 0, or if it's not greater than 0, then it's not smaller, but we still need to move left to nil, which is We need to basically just trash the value because we're not going to do anything with it. Yeah, okay. But if it's greater than 0 here, then you're going to move left into ACC and save, which is going to be the new low value, and then end just right there. So for this one, we're going to do a very similar thing. I'm actually going to copy this because it's going to be very similar. But obviously, we're going to be, okay, so this is going to be moving left to right. And then I'll handle this real quick. It's just going to move left to ACC, move ACC left, and move ACC left. Okay. So for this one, though, it's going to swap. And if it's equal to 0... Now, one thing we need to do, one additional thing, let me see here real quick, is that if when we move, let me see here, we need to do one more check, I think. Because we need to do the terminating part. I think the problem is that I'm just going to run out of space here. All right, so I think I want to see if we can fit this here. So the problem that I'm having is just trying to figure out, because right now I don't do any checking if we actually are being passed as 0. So we're going to need, I know we're running out of room, but we're going to see if I can do this. So we're going to move up into ACC, and then if the value is, let me see, if it's not 0, NZ, we could put NZ here. So the problem I'm having is I really need to have one more line here to say if it is 0, then save it. Maybe I can do this. And then get rid of the end label. And then here we can say save. So I think that will properly reset this if, well, let me see here. All right, so I did some thinking, and I think I'm going to actually, we're going to go back to the segment list, and I'm going to try again. I thought up of a slightly different way to do it. So the problem I was running into with the previous way I was trying to do it is I was trying to do, in what was in this node, I was trying to do too much in one node. So I did some thinking, and I think I have a way here that better splits up the responsibilities. So let's see if I can get this to work. So this one's going to essentially do the same thing, because I think this one was good. This one was very simple. Okay. Here, up to ACC, it's not 0. So here we're checking if we're caching out, if we're going to go ahead and pass our value. So if it's not 0, we go down there. If it is 0, then we would want to do a SWP and then move ACC down. Oh, and I think that'll just kind of work because as far as resetting. So this is obviously the path where we're caching out, we're sending the value to output, and we want to reset everything. So here we moved up to ACC, and the value in ACC was 0. We swapped, so now 0 is going to be in BAK. Although, actually, no, because the resetting, okay. The resetting should be setting this to 999. Yeah, that's kind of annoying, because that means that we need to move 999 into ACC and SWP. Or SAV. Well, we'll see. I'm reducing the responsibilities. So that should do all of the resetting. Then I'll probably end up jumping to the end. But for now, I'll put JMP end. But we'll fix that later. So if it's not 0, then the minimum is going to be in BAK. To reduce instructions, I'm just going to go ahead and pass them in this order. So I'm going to pass. We're going to do move ACC left. SWP, move ACC left. All right, so the whole point of this is that we're going to be passing, so the value was not 0, so we need to figure out if it's smaller. BAK would, in this case, be storing our small value. ACC has the new value. We're going to pass the new value and then pass the old value to the left. It's going to do the calculations. We'll do that in a second on which one's the minimum, either the original or the new one. Then it's going to pass it back. And so then we want to move left to ACC and SWP. Yeah, and it should be just as simple as that. And then over here, we're going to do the calculation. So now I need to make sure we're accepting. So first we're getting the new number. Okay, so move left in ACC, SAV, move, or sorry, not left, right. And then we move right into ACC again. Or actually, no, we can do this differently. Just move right in ACC. So that's the new value. And then we can sub right. So this is new minus old. So like if the new one was 5, so it's smaller. So we get past the new one first. And then the old one's 10. So if the new one's smaller, then it would be negative. Let me think about this. Yeah, I think we do need to do something slightly different. So move right in ACC, and then I think we do want to save because we want to store the new value. Then we want to move right in ACC, or let's kind of do what we did last time. All right, so we're going to move right up because the kind of problem that I'm running into is I really need to have 3 registers for this because I need the old value, the new value. I need both of those accessible because at the end of this I need to fit, pass back either the new value or the old value. And then I also need like a working register where I can subtract them and check whether or not it's less than 0. So we're going to use this. And the equivalent here, I really wish this one was available. I'll probably end up passing these down to here and then doing it kind of here with, let me see here. So here, because we have this and we would need to have a one here and an additional one. So if we had this one here, because we need to pass it through. Because the problem is on this side, I can't do this and then that. What if I moved this here? Then you'd have this, and I could do like, well, you could end up moving it. So this was the main one. I don't think that really helps though. This could be the main one, and this, and then, yeah, it's actually going to be a problem when I need to go over to the other side. Let me think. I could probably do this just with this register. I just need to do it a little bit differently. So we're getting the new value. We could store it in BAK. We could sub that value. Then we could offer it again. So what I'm thinking here is when we do this, so we're going to move ACC to left, swap, move ACC left, move ACC left. So offer up the second one twice. That's probably what I'll just end up doing. So let's kind of go back to what we're doing. So we want to save that definitely. Then we're going to sub right. And then once again, if the value is less than 0, then the first value that we passed was smaller. So if the value wasn't smaller, if the second value or the first value was bigger, then we want to return the second value, in which case we would just say move right, because remember it's going to offer it up again, and that should work. Move right from input to output. JMP end, and we'll have to put an end. If it's less than 0, then we want the original value, which we just need to do SWP to get the value back, and then we get to move ACC right, and then end. I think that will work. Oh, we just need to do that if you're either passing that value back, but you do also need to just move right to nil, because it's going to pass it again. If we don't need it, we just need to discard it. Okay. And we already know this, moving ACC down, and in this case, we just need to move up, down. So let's try doing the same thing on this other side. So on this side, it's going to be very similar. Just this is the min side, this is the max side still. So if we're on the max side over here, move up into ACC. If it's not equal to 0, then swap. Or if it's not equal to 0, jump, then otherwise swap. Move the ACC down. I can just say here, move up, down. Move up, down, because all these are doing. So the thing is, though, we need to do the reset. And I know for this one, we technically don't need this line because in this case, 0 is the min. It would already be 0. We can just save it. This is moving. Okay, so instead of moving from up, we need to move from left to ACC. That's still fine. But this would be right. And you're mainly interacting with right here. And then also right. So this is still going to be the same because this one is actually the only place where the logic is going to mainly change is here, because this is the one that's actually figuring out which one's smaller. So here we're going to move from left to ACC, and you're going to sub left. In that case, we were saying if it's less than 0, then it's smaller. So it's still the same case here, but we want to change this to GZ. So if the new value is bigger, it's going to be greater than 0. Jump to GZ. Here you can just say move left, left. It's greater than 0, swap, move left and left. Let's give this one a shot. Okay, we ended up getting a wrong value for that first one, so let's step through that. Oh, because so initially it's not setting this to 999. Okay, let's see here. How am I going to initially set that to 999? Wish you could just modify the initial value. Because it's only a problem on the left side here. This side will be fine. So it's going to move right in ACC, save it, sub right. So it's going to get like it's going to get a 14, then it's going to try to sub a 0. All right, so, oh man, I'm trying to figure out a way to do this thing for it would only do it once. It's kind of a weird thing to try to set up with this setup. Because these nodes and everything are all really set up for repeating stuff. But I'm going to try this. So this is going to be kind of dumb. So we're going to have this one move 1 to the right. And then we're going to have it do move 0 to the right. JRO -1. So this should pass 1 to the right and then continuously pass 0 to the right. And then in this one, before we accept any values, and we'll fix this at the spacing in a second, we'll move left to the right to ACC, basically GGZ, GC. So if it's not greater than 0, then we just want to do the normal stuff. Well, we do it the other way where we pass a 1 and we otherwise pass a 0, because then we can say JEZ. Or you can say JNZ. It's not 0. You can do all the normal stuff, but if it's, or let me see. Yeah, if it's not 0, do all the normal stuff. But if it is 0, it'll go here. And basically, if it is 0, then you're going to want to move 0 down. And that's going to tell this to reset, but it's also going to tell it to pass whatever its value is, which at the start will be 0. If we passed in a 0, it would immediately swap and move this down. So then we just need a piece of logic here saying move up in ACC, JNZ, and Z. Or we can just do JEZ, EZ, and have EZ be here. So the whole idea is if it gets past a 0, it's obviously not the right answer, so it doesn't output. All right, let's try that. Now that, oh, I was gonna say now it seems to be working, but I guess not. Oh, well, let me actually. So the right one, the left one's fine now, but this one seems like maybe it's not resetting properly or something. Yeah, it's not properly resetting. Let's go ahead and, all right, that was specifically on the third one. So in here it still has, let me see, 0 and ACC. That's all we really need. All right, that one took a bit of thinking and I had to redo from my initial design. Looks like it is slightly best or slightly worse than what most people ended up putting for cycle counts. I use one more node. And so it looks like it's not particularly good of an answer, but it's also not horrible. So I think that's acceptable for this. All right, so that's going to be it for this one. I'm sure a lot of that's going to be cut out, just like in the couple of them ago I did. This one was like really easy, signal pattern detector, but then these other ones took me a little bit longer. So we'll see how these go. We're going to get to some image stuff later, it looks like. Actually, these ones look not too bad at the start here, maybe because you're kind of being introduced. We'll see. We'll see. But all right, that's going to be it for this one. I hope that helped you guys out. Thanks for watching. Catch you guys next time.